Last time we have seen the method of undetermined coefficient. We want to solve the non-homogeneous linear differential equation. Mostly for our discourse has to be the second order non-homogeneous linear differential equation with constant coefficient. And here the method of undetermined coefficient is based on the assumption that this q of x is the solution of some homogeneous linear differential equation with constant coefficient. And then with the help of this, we convert this non-homogeneous linear differential equation into the homogeneous linear differential equation, and then we obtain the solution of this given non-homogeneous linear differential equation by the method of undetermined coefficient. And last time you have seen this example. We solved this example by using the method of undetermined coefficients. Now we want to see the another example. We want to see this solve the equation d square minus d minus 2 of y is equal to 6x plus 6 e to the power minus x by using the method of undetermined coefficient. Now in the solution, as usual, we first find the complementary function of this non-homogeneous differential equation. Therefore, we write the given differential equation is d square minus d minus 2 into y is equal to, or of y is equal to 6x plus 6 e to the power minus x. We call this as to be equation 1. Now from this, the associated homogeneous differential equation is d square minus d minus 2 of y is equal to 0. From this, we consider the auxiliary equation is m square minus m minus 2 is equal to 0. We want to factorize this as to be m minus 2, m plus 1 is equal to 0. Therefore, m is equal to 2 minus 1. The auxiliary equation have the roots real and distinct. Therefore, complementary function yc is equal to c1 e to the power 2x plus c2 e to the power minus x. We know this thing. Up to this is very easy part. Now we want to solve this differential equation by using the method of undetermined coefficient. For this purpose, here q of x is equal to 6x plus 6 e to the power minus x. And now from this, we want to find the homogeneous linear differential equation with constant coefficient whose particular solution is 6x plus 6 e to the power minus x. And we have seen that how to find that homogeneous linear differential equation with constant coefficient. Now here if we see the first term in q of x has to be 6x. There is no term of cos, there is no term of cos and sine. Therefore, from this we can say that the roots are not complex, roots are real. Now, here there is a term of x. This indicates that the roots are to be repeated. Now, which root is to be repeated? There is a term of e to the power mx here, but there is no term of e to the power mx. This means m is 0, means the 0 root repeated twice. This is the first Now from the second term, 6e to the power minus x, again the roots are real since there is no trigonometric term sine or cos, and the next roots are non-repeated. There is no term of the type x to the power m, and this root is minus 1 e to the power mx. M is minus 1, means minus 1 is the root. Therefore, the differential equation is, what are the roots of this homogeneous differential equation or the auxiliary equation of the homogeneous differential equation, whose solution is 6x plus 6e to the power minus x is minus 1, 0, 0. We write the minus 1 first and then 0, 0. Here, since this root minus 1 comes to be in the associated homogeneous differential equation or the auxiliary equation of this non-homo or homogeneous differential equation, we get this. Therefore, we write the roots has to be minus 1, 0, 0. Therefore, what is the differential equation? D minus minus 1, it becomes d plus 1 into d minus 0 whole square, means d square operate on y is equal to 0. Therefore, we obtain the differential equation as to be d plus 1 into d square operate on y is equal to 0. We give them as to be equation number 5. Therefore, from this, we obtain this g of d as to be d square into d plus 1. What is our g of d? D square into d plus 1, and then we operate this d square into d plus 1 on equation 1, and also from this, since this 6x plus 6 e to the power minus x is a particular solution of this homogeneous differential equation 5, we obtain, if we operate d square into d plus 1 on 6x plus 6 e to the power minus x, this becomes to be 0. Therefore, we operate this operator g of d, means d square d plus 1 on both the sides of our equation 1. Therefore, we get d square d plus 1, again d plus 1 d minus 2 of y is equal to 0. And the roots of this homogeneous differential equations are to be 2, minus 1, minus 1, 0, 0. First two roots are roots of the auxiliary equation. Now, therefore, we get its general solution is y is equal to c1 e to the power 2x plus, since this minus 1 repeated twice, corresponding to this, we write first the term c2 plus c3x into e to the power minus x. c2 plus c3x into e to the power minus x, and then we separate this bracket, we obtain these two terms, and the next terms from this is c4 plus c5x into e to the power 0x, but e to the power 0x is 1. That's why I have written here directly c4 plus c5x. This is the general solution of this differential equation, but we see that these first two terms are belongs to YC. Therefore, we call this as to be YP dash, or here we call for our simplicity YP. Here, therefore, YP is what? C3x e to the power minus x plus C4 plus C5x. This is a particular solution of given non-homogeneous differential equation 1. But we know that particular solution does not contain the arbitrary constant. That's why we want to find the C3, C4 and C5, and since YP is a particular solution of given differential equation, therefore YP satisfies differential equation 1. Now for that purpose, from yp, we find yp satisfies this differential equation 1. Therefore, we get yp double dash minus yp dash minus 2yp is equal to 6x plus 6e to the power minus x. We call this as to be equation 6. Now from this equation yp, we find yp dash, yp double dash, and we substitute the value of yp, yp dash, yp double dash in equation number 6. Then we get this is equal to 6x plus 6c to the power minus x. Now by equating the coefficient of like powers of x, we have here consider the coefficient of like powers. We simplify this, consider the coefficient of x, coefficient of e to the power minus x, and then the remaining terms. We obtain this minus 3c3 is equal to 6. See here, if we consider the coefficient of e to the power minus x only, here it is minus 2c3, only e to the power minus x. This is minus c3, means it becomes minus 3 times c3. Minus 3 times c3 is equal to 6. This is the first we obtain. Minus 3c3 is equal to 6. Now the second, collect the coefficient of x e to the power minus x. Here it is c3. This minus minus plus c3 means 2c3. Here minus 2c3. It becomes 0. Plus 2c3 minus 2c3. This is equal to 0. Now here we may take this, the coefficient of remaining terms. Select the coefficient of x e to the power minus x, c3 minus minus plus c3, 2c3, c4 plus c5x by equating the coefficient of both the sides. It is minus c5. We collect the, now the remaining terms. This gets cancelled. We get this. This gets cancelled. Minus c5 and this minus, if we collect the coefficient of x only, coefficient of x only. Here the coefficient of x is minus 25 is equal to 6. And the remaining terms, this gets cancelled. Here minus c5 minus 2c4 is equal to 0. Means we get these three equations. Minus 3c3 is equal to 6, minus c5 minus 2c4 is equal to 0, and minus 2c5 is equal to 6. Therefore, from this, c3 is equal to minus 2, c5 is equal to minus 3. Substitute here, we obtain c4 is equal to 3 upon 2. Therefore, we obtain the value of C3 is minus 2, C4 is 3 upon 2, and C5 is minus 3. We substitute these values in YP. Then we get YP is equal to minus 2x e to the power minus x plus 3 upon 2 minus 3x. And then we write the general solution of given non-homogeneous differential equation is y is equal to yc plus yp, and substitute the value of yc and yp. This is the solution of given non-homogeneous linear differential equation by the method of undetermined coefficients. I hope you understand. We see one more example of this type. Consider this. Solve the equation d square minus 1 of y is equal to e to the power x sine 2x by the method of undetermined coefficient. Now, to find the general solution of given differential equation by the method of undetermined coefficient. For this purpose, the first part is as usual. First, we find the complementary function. To find the complementary function, first we consider the auxiliary equation. And here the auxiliary equation is m square minus 1 is equal to 0. Therefore, its factors are m minus 1, m plus 1 is equal to 0. Therefore, m is equal to minus 1 and 1. Therefore, roots are real and distinct. Therefore, yc is equal to c1 e to the power minus x plus c2 e to the power x. This is our complementary function. Now, to find the solution of this given differential equation by the method of undetermined coefficient. For that purpose, we want to find another homogeneous linear differential equation with constant coefficient whose particular solution is e to the power x into sine 2x. Now we want to find that homogeneous differential equation. How to find? Now we have seen that this term contains the trigonometric term sine ax. Therefore, roots must be complex, right? And we know that complex roots are always occur in conjugate pairs. Now we want to decide which is the complex root. E to the power ax means a is 1 and b is 2. A is 1 and B is 2. Therefore, roots are what? 1 plus 2i and 1 minus 2i. There is no term of x to the power m of this type or powers of x. Therefore, roots are non-repeated. Therefore, what are the roots? 1 plus 2i and 1 minus 2i. From this, we are able to write the homogeneous differential equation g of dy is equal to 0. Now, how to write this? This is to be m into bracket 1 plus 2i into m minus 1 minus 2i. In that way, or we write in terms of d minus 1 plus 2i, d minus 1 minus 2i. And then we operate this operator on the equation 1, then we get this equation d minus 1 plus 2i, d minus 1 minus 2i, d square minus 1 of y is equal to operate this operator d minus 1 plus 2i into d minus 1 minus 2i on e to the power x sine 2x, and this is to be 0. That's why I have written here this is to be 0 directly. Therefore, what are the roots of this auxiliary equation? This auxiliary equation have the roots minus 1, 1, and 1 plus 2i and 1 minus 2i. Therefore, its general solution is y is equal to c1 e to the power minus x plus c2 e to the power x plus e to the power x c3 cos 2x plus c4 sin 2x. But we know that the first two terms belongs to yc. Therefore, what is the yp particular integral of the given non-homogeneous differential equation is to be e to the power x yp is equal to e to the power x into this bracket c3 cos 2x plus C4 sine 2x. But we know that this particular solution does not contain the arbitrary constant. Therefore, we want to find the value of C3 and C4, and for that purpose, YP is a particular solution of given differential equation 1. Therefore, YP satisfies this differential equation 1. And with the help of this, we find the value of C3 and C4. For that purpose, we find this Yp satisfies the differential equation 1. We get Yp double dash minus Yp is equal to e to the power x sine 2x. Now from this we find Yp dash, Yp double dash, and we substitute this value to be here. Then we obtain this. Yp dash is this, Yp double dash is this. You do these calculations, you only take the derivative. Yp dash, Yp double dash, and then substitute the value of this Yp double dash and Yp in this equation 6. We get this. Now compare the coefficient of the like terms. Then we get the minus 4c3. If we compare the coefficient of say e to the power x sine 2x on the left hand side, e to the power x sine 2x is comes to be what? Minus 4c3 minus 3c4, and again this minus c4 means it becomes minus 4c4 minus 4c4 is equal to 1, and the coefficient of e to the power x cos 2x is minus c3 plus 4c4, and this minus c3 it becomes minus 4 times c3 4c4. There is no term on the right hand side, therefore we take its coefficient is to be 0. There is no term of the type e to the power 2x cos, sorry, e to the power x cos 2x. We get these two equations, and if we solve these two equations only by taking the addition of this, we get minus 8c3 is equal to 1. Therefore, c3 is equal to minus 1 upon 8. And if we substitute this in any one equation, we get c4 is equal to minus 1 upon 8. And we substitute these values of c3 and c4 in Yp. Therefore, Yp is equal to e to the power x minus 1 upon 8 cos 2x minus 1 upon 8 sine 2x. And then we write the general solution is y is equal to yc plus yp. And this is the general solution. Means we solve the given non-homogeneous differential equation by the method of undetermined coefficient. We have seen up to 3 examples on this type. In the next lecture, we see 2 more examples, if possible, of this type. And I hope then you understand this method properly. Now we stop our today's lecture.